Hi, this is Tom, and welcome to lesson 27, the weighted tree. Here we go. What we'd like to do is we're going to go through a few examples to build the idea. So the first one is flip a coin. Just once, just flip a coin. And we're going to draw a tree to represent what we've just done. So here's my coin that we're going to flip. We flip the coin, and what can happen is either it comes up heads or it comes up tails. Now, notice that there's our sample space. Whoa, I don't know why that happened. Our, our sample space is just two things. So n is 2. And we can say then that the probability of a head is, well, there's only one way to get that. And there's two things that could happen, so it's 1/2. And the probability of a tail, well, that's also 1/2. Now, this problem works really well because the probability of a head or the probability of a tail, well, that's the same either way. So let's take a look at, well, what happens when things aren't always the same? Let's go. So what I'd like to do is imagine we have a multiple choice test. Multiple choice test, and from now on we'll just abbreviate it as MC for multiple choice. And multiple choice test of one question. That's right, a really simple test. One question, and then the question has three possible answers. Of which only one is correct. All right, so imagine this. You're going to take your test, and you've been studying diligently. One question. Now, and we'll just put here a little 1 for that's just the first question, and in this case, the only question on the test. Well, you could either choose an A, you could choose answer B, or you could choose answer C. And we'll put a little star by C and assume that C is the correct answer. Now, let's think about this. So we can say here that the probability of an answer of A is 1/3 because there's only one way to answer A, yet the sample space has size 3. So we'd say the probability of an A is 1/3. Probability of B is 1/3. And the probability of C is also 1/3. Now, so far there shouldn't be any surprises, but let's take this problem one step further. So this time the multiple choice test has two questions. Again, each one with three possible answers. And I'll write that, each with three possible answers. Okay, so again, we're going to draw a tree to show what can happen. Draw a tree. Now, think about when we began counting in our last lesson, that on the first question, if I asked how many different answers are there on the test, you'd say, well, for the first question, there's three possible answers. And then on the next question, again, there's 3 possible answers. So if our counting is correct, I'm expecting there's probably 9 different branches to this tree. Well, let's draw the tree and find out. So here we go. Here's our test that we're going to take. Now, and we'll keep track up here. Let's maybe do this. So here's question number 1. So when you come to question 1, you can answer A, you could answer B, or you could answer C. And again, remember that C is always the correct answer. Now, then let's see what happens. You come to question 2. Let's say originally you picked an A. Well, this time you can, on your second question, you could either pick A or B or C. Again, C being the correct answer. But let's say you picked B on the first question. On your second time, you could either pick A or B or C. Or maybe you got the first question right, but then you could pick an A, B, or a C. Wow. So let's do this. Notice if we count these up, let's count these up. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 different things that can happen, like we were expecting. So let's do a few things. Let's see here. Let's find a few probabilities. I'm going to write here the probability of each one of these outcomes, the probability of X. So the probability here, and we'll write the first one in full, the probability of an AA, well, there's 9 things total, and an AA, there's only one AA, so that's 1/9. I'm not sure why it got strange like that. 9th. Now, the probability of an AB, well, again, that's 1/9. And if we continue this down, the probability of an AC, that's also 1/9. And we'll go all the way here. The probability of BA is 1/9. The probability BB, that's also 1/9. C or BC, 1/9. CA, 1/9. Probability of CB, 1/9. And finally, the probability of CC is 1/9. Now, I can add up all of those probabilities. And if I do, I would say the sum of all of those probabilities is 1. Now, in the same way that you can add all of them up, you can add different probabilities based on what you're after. And so we're going to try. So let's do this. We're going to find the probability of a score of 0 out of 2, meaning you missed both questions. So let's see how you could do that. Well, we'll do that in green for the first one. So notice that I could get this AA, those are both incorrect. AB, those are both incorrect. Now AC, well, one of those is correct, so that doesn't count. Oh, I could get a BA, a BB, and notice all the rest of these have a C in them. So none of those would be 0 correct. So I could say the probability of 0 out of 2, well, that's the same as the probability of an AA, probability of AB, the probability of BA, and the probability of BB. Okay, and notice that each one of those is 1/9. So I could write this as 1/9 plus 1/9 plus 1/9 plus 1/9, and I add all those together for a total of 4/9. So the probability of a score of 0 out of 2 on your test was 4/9. Now let's do this next one. the probability here of a score of 1 out of 2. Well, let's do this in a different color highlighter. How about the pink? So 1 correct, well, here's 1 correct. Oh, here's another one with just 1 C and another one and even another one. And so if I count those up, I had to say the probability of 1 correct. Well, I have 1/9 for each one, and there's 4 of those. So I'd say that's 4 times 1/9, or also 4/9. And my last one I want to do here is the probability of a perfect score, meaning 2 out of 2 correct. And if we pick another color like this pretty blue, that's right there. That's this very last one. And that is, it only happened one way, and that was 1/9. Now look at this. If I added the probability of 0 out of 2 plus the probability of 1 out of 2 plus the probability of 2 out of 2, well, that would be 4/9 plus 4/9 plus 1/9. In other words, I've used my sample space, so 4 plus 4 is 8, 1 more is 9, so that's 9/9, which is 1. So now we haven't made a weighted tree yet, but what we have made is we've made a tree and we've found the associated probabilities. Now there's one more thing that we wanted to do here. There's one more thing, and that is what if, notice here that the probability of an A, well, that was 1/3. The probability of B, that was also 1/3. The probability of C was 1/3. So I'm going to write the probability of on each branch. And so let's do this again. When I go to my second question, the probability of an A, well, that's still 1/3. The probability of a B, that's still 1/3. And the probability of a C is still 1/3. And you could continue and write 1/3 on all the rest of the branches. Now, here's the interesting part. Pick any branch. So let's use this blue branch, the one where we got both correct, because that's always how we want our scores to go. That means I went down here and I picked answer C, and then I went down this bottom branch and I picked answer C again. And we already know from our sample space that the probability of CC, or 2 correct, is 1/9. Now, using my weights, so I think there might be something on my screen that's causing that. So using the probability on the branch, or branches, can we get 1/9? And the answer is yes. Notice that we know the answer, that's 1/9. And we also know that on each branch there's a 1/3. Oops, a 1/3. And notice if you multiply 1/3 times 1/3, that equals 1/9. In other words, if you multiply the probability that we wrote on the branch, you can find the probability of the associated outcome. So, in the next video, we're going to condense this and see how we can use this even more. See you soon, and thanks for watching.